Okay, on this course what I really want to do is get into building the applications, because they're a lot of fun and you're going to learn a lot more about programming microcontrollers with the Arduino if we just get straight into the actual examples. So that's what I want to aim at. So this first video, what I'm going to do, instead of taking a long time explaining how to install the software and set up the Arduino to connect it to your computer, I'm going to give you the best place to find out how to do that, and that's directly on the Arduino site. So in front of you here you can see I've already got to the website. So this is the first thing you want to do before you go through any of the other of these online lectures, is to just go to this page, and this is going to help you set everything up. So first of all, go to www.arduino.cc. By the way, I'm going to put all the URL links to everything I refer to in the comment section below this video, and maybe up on the screen as well. So you've got all those, yeah? You can refer to those when you want to. So anyway, we're going to go to this page first. Now when you're on this page, you want to go to the learning section. So if you click on the learning, and then it says get started. Now go directly to get started, so we click that. Now on this page, don't worry too much about any of what it says at the moment. What we want to do is just get you up and running, yeah? So you've got three options here. Either you're running on a Windows machine, or you're running on a Mac machine, or you're running on a Linux machine. Now depending on what machine you're running on, you'll want to go to one of these. Now it turns out, because the Arduino was developed on a Linux system, it's actually a lot quicker and easier to use a Mac or a Linux machine. It's normally the other way around, but if you've got a Windows machine, it's a little bit harder, but really it's not that hard either. But we'll go to the Windows one and I'll just show you. There's the Windows one. This is the one you'll need if you're on the Mac, so there's a different URL. I'll put these below. This is the URL for the Mac, and this is the URL for if you're using a Linux machine. So it's Mac, Linux, and the Windows one I've just come to. So we're just going to quickly look at the Windows one, because that's a little bit more trickier than the others. Now all you've got to do is basically, you can see there's 10 headings here. You just got to read through each one. Not much to it. You've got to just work through it gradually. Make sure you understand everything. With the board, okay, you're going to get a board. You've got your Arduino board. I'm using an Arduino Mega board. It looks slightly different to this one, but they're all the same. They all got the same connection. So it doesn't matter what board you've got. These instructions will apply to any of the boards you've got. But I would recommend you start off with something like this Arduino Uno if you're going to buy one. They're about £35 or something. Just start off with that. Give you the what you'll get is the board and a cable. With that cable, you just plug it into your PC or your Mac. Now, when you plug it in, it's not then just going to work. You're going to have to go through these steps. So this is step one. It says get an Arduino or a Arduino board and a USB cable. So let's assume you've got that. Then you're going to download and install the Arduino software. So this is step two. This takes you through all the steps you need to install it. So just read this. It's very easy. Just carefully read through the instructions. It tells you everything you need to do on a Windows machine. Then on to step three, connect the board. So you'll connect the board at this point. So you'll use your USB cable and plug it into your PC. Step four. Now this is the only bit that can be that can be a little bit tricky, but it's not really. You just got to follow these instructions again. So this is where you have to install the board drivers. A lot of people get hung up on this, but don't. Just read these instructions carefully. And basically what it is, it's pieces of software that allow your PC to talk to the Arduino board. So you're going to need to get these installed. Yeah, they're not installed on a Windows by default. To make this even easier, what they've done, the people at Arduino, they've actually given you, I'll just quickly go to that window so you can see. I'm going to click that now. And I've just opened up a fresh window so you can see. Look, they've given you actual steps. So they're basically taking you by the hand here and walking you through every step about how to install the drivers. So you really should be able to do this. So we'll run it now so you can see what's going on, and I'm just going to assume that your system will work okay, yeah, and we'll just go on from there, because I really want to get into doing some examples than spend too much time on how to set it up. So it's all there for you. It's on this website. You should not have a problem really. It's very straightforward. In fact, the Arduino is the easiest board to actually connect to a computer, so it should be very, very straightforward for you. I mean, it's easier than a printer, for example. I mean, with a printer, you know, you've got printer drivers, it's the same sort of issue, but this is very easy. So don't worry too much. I probably made it sound more scary than it needs to be, but just get to this point and then we'll carry on. Okay, so I'm going to assume that you've connected everything up correctly, and now we're going to run the blink sketch. So first of all, let's open the software. So wherever your software is stored on Windows, just click the Arduino icon, or whatever the package is, .exe in Windows case. Click that, and then wait for the package to open. I'm using Raspberry Pi at the moment, so on a Linux system, so it's a little bit slower than your Windows system if you're using Windows. So this is what you'll see. You'll see this software pop up on the screen. This is the Arduino software. It's called the IDE, which is the development environment for writing code to move over to the Arduino board. So what we do is we write the code on the PC or the Mac or whatever you're using, and then when we compile it, it automatically will go through the USB cable and install itself on the Arduino board, and then whatever peripherals or sensors are connected to the Arduino board can then be operated by the software you've just written. So you compile it and move the software over to the board. So to test it out, what you'll always want to do before you do anything is just run the blink program. The reason you want to run the blink program is built into the Arduino board is a little light which is connected to what's called pin 13, and this will activate without us having to connect up any LEDs. So it's built into the board. One of the LEDs is built in just for this purpose, for testing. So we're going to use that built-in LED and check that it's working. So the first thing you'll want to do is go to File, and then go to Examples, and then go to Basics, and then open this program called Blink. So you just click that Blink, and a new window will open up, and in there will be the program that we've just selected. So along the top here, just move to the second button from the left hand side, and you'll see the text appear on the right there, says upload. So basically when you finish writing your piece of code here that controls the board, then you'll want to compile it and then move it via the USB cable onto the board, and that's what clicking this button will do. But for first we do that, one quick thing you want to do is you want to go to Tools, and this will be written in these instructions that you went through on the setup. Will explain this. You want to set up your board, and in this case my board is the Atmega 1280, but yours might be different depending on what board you've bought. So it'll be quite obvious because the name of the board will be written on the board that you've purchased. So just select the correct board, and then when you've done that, you'll also want to collect the serial port. Now depending whether you're on Windows or Mac or a Linux system, this will be different. So again, read those introductory documents and connect the serial port. You need to connect the correct serial port. Now if you're not sure what the serial port is, a quick trick for that is to actually disconnect the Arduino, start this software up, and then go to the serial ports, and any ports that are in there that are not the Arduino board will show, and then you can just quickly write those down on a piece of paper, connect up your Arduino board, run this software again, and then you'll see another one appear, and that'll be the one you want to connect to. And if you're still not sure, just try every one until it works. Basically, that's a lazy way of doing it. Open it up, and if you've got several in here, just try every one until the compile works. Then you know you've got the right serial port. So the important thing is to get the board correct and connect the right serial port. Once you've got those connected correctly, then you can compile it. Then it's all connected, and it should just go straight over to the board. So let's run that now and see what error messages or what warning messages we get. Down at the bottom in this screen here will appear all our messages. So let's just run that and see what happens. So you can see first of all it says compiling the sketch down here. And on this Raspberry, I'm running this on the Raspberry Pi. It's a little bit slower, so that's not too slow. It's actually come through. There you go. At the bottom you should see it says AVR Dude done. Now AVR Dude is a kind of software that sits behind this, but you don't need to worry about that. It's just the message. All you really want to see is thank you, and there's no error messages. Now when you've got no error messages, it means that you know it's been successful. So then when you go over to the board, you should see it blinking. So I'll show you that now. So here's our Arduino board that's been we've sent the program over to the Arduino board. Notice if I pull out the actual USB cable, it won't make any difference. You can see once that program has been installed, it's still blinking. So now what's useful about that is you can place this Arduino board in a box or anything else. So if you're later on when you build more sophisticated projects, you can actually build this as part of the project. This little board can be slotted into the tin or the container that if you're making a robot or something, then this whole board can go in there because the program's now installed on this board. You don't need your computer anymore. So you can see that the board's blinking, everything's worked, and so now we can have a look at this program and see exactly how it works. One thing I would recommend is all of those setup steps, just write them down a little. Keep a notebook and title the notebook Arduino projects. And if you keep a little notebook, then at the front of that notebook you can write down all of these installation steps. So if you ever have to do it again, or you get another machine you want to do the process again, you've got it all written down. That's always a good tip, because often it's easier if you write it down in your own words what you did, and it makes it easier to remember too. So that's a good tip. So once you do that, from now on I'm just going to assume that you set everything up correctly, your Arduino board is working correctly, and we can just now concentrate on the sketches that we're going to write and what we can do with this board, which is much more interesting. So the first thing we're going to look at is just quickly go through this program and explain how it works. It's a very simple program. This pin 13 has got a little LED that's on the board. As you saw earlier, it was flashing. So, and that, we set up a label for that to tell the computer what pin that is, and we're going to give that a label. Now, int means it's an integer, okay, so it means it's a number. That's all that means. That's all we need to think about. LED is a name we're going to give to that number, and the number we're going to give is 13. So whenever this program refers to LED, it knows that it's number 13. Now that's setting up a label in the program. The best way to learn is to actually do things, yeah? So I'm not going to go through how to program. You're just going to pick that up as we go along, and you'll just learn it quicker that way. You'll learn it without even meaning to learn it. So that's the best way to do this. A lot of people will try and teach you the programming language, but you'll learn it anyway. So if we go down now, it says void setup, and you'll see there's a curly brace, and then there's another text in there. Now the text with the two slashes in front, they're always comments. They're useful comments to explain to you what's going on. So the first comment above this void setup command is the setup routine runs once you press reset. So this whole program will run, and the first thing it will do when it moves over to the board is it will run this setup. So the setup initializes the pin as an output. So this is what it does. When we use this command here called pin mode, what we're actually saying is allow the LED, which we know is equal to 13. So what it's saying is pin mode 13, make that an output. So that's basically what it's actually doing. So behind the scenes, it's going to say, right, I'm going to allow pin number 13 to be an output. So we need to specify what the pin is an output or it's an input. So that's all that does. Then it will go into this loop. Now this loop runs forever on the board. So when we've placed this on the board, if we turn off the power off the board and put the power back on, it's going to jump straight into this loop, and it will keep continuing this loop all the while the power is switched on. So this loop will run forever. So what will happen, it'll run that command, Digitalwrite LED high, I'll explain it in a minute. Then it'll delay for 1000. Then it will Digitalwrite LED low, and then it will delay for 1000, and then it'll jump round and do that whole loop again. So what does Digitalwrite mean? Well, Digitalwrite is another function, and what it's saying is the LED, in other words pin 13, we're going to make that high. Now high means that that LED will get a voltage between about 2.5 and 5 volts. Whenever it gets that voltage, the LED will light up. Then delay, when we say 1000, we're saying 1000 microseconds, which is a second. So it'll wait a second, and then it will Digitalwrite pin 13 low. So now it's set its low. In other words, it's going to set it between a voltage below 2.5 and above 0 volts. That means the LED won't light now. It will be off, and then it will delay for another second, and it'll do that whole loop again. So you can see all it's doing is it's turning on the light and turning off the light, turning on the light, turning off the light. It's going to do that forever. So that's all this program does. It sets up pin 13 as an output pin. When it sets the voltage high, that LED will light up, and when the voltage is low, the LED will go off. So that's all this program does. It's nothing other than that. So that's the first program. Now if we want to speed up the on and off transitions, how would we do that? Well, all we got to do is change that from 1000. Let's say change it to 100 instead of 1000. Now we've got 100 microseconds. So now when we look at it, if we compile it again, let's see what happens. Now, so what we're doing now is we're replacing the earlier program with a new program now that's going to be burned onto the Arduino. So that's done now. It's done. If we now go and look at the Arduino, we'll see that the LEDs are now flashing on off much more quickly. Okay, so I now just increased it, and you can see now that the flashing LED is now flashing on much more quickly. The other interesting thing to point out about this, of course, if you pull the power and put the power back in, it'll remember the last program that's installed. So for the same reason as pulling this, we can pull this out, and if we pull the power now, obviously everything will switch off. But what makes it useful is when we put the power back onto the board, it will activate the last program that we compiled over to it. So it will remember that program and always run it every time we plug this in now, this board, unless we overwrite it with a new program. So there you go, we're back to it, and you see it's almost instantly back on. So that's good. It means once we've developed our projects, then we can burn our program to this board and use the board in the project in any way we want. So that's it. That's your first program, the Blink program. The next program we're going to look at is a little bit more interesting. We're going to adapt this Blink program to actually increase the Blink's speed of transition on and off depending on what's called a light dependent resistor. This is quite interesting, so I'll explain how that works in the next video. So that's the first video. I hope you've installed everything and got everything working. If you're at this point now it'll get a lot more interesting as we go forwards.